Hi everyone, welcome back to the Sagar Techgate. In today's video, we are going to talk about a very important concept in Verilog, functions and tasks. As your designs get more complex, writing a clean and reusable and well organized code becomes essential. And that's exactly where function and tasks help. They reduce a code duplication, improve the readability, and let you break big blocks of logic into smaller and manageable pieces, just like a functions in a C or Python. But we should know that what is the difference between a function and task? When should use and can they have delays? Don't worry. So we will discuss all of this with a simple, clear examples, step by step. So we won't go into too much depth here because Verilog has a certain limitations with a task and functions. For detailed concept like dynamic behavior or maybe recursion or automatic variables, so we'll cover them in the System Verilog playlist. By the end of this video, you will know how to write your own functions and tasks, where to use them, and why they matter. So especially in OTL design and test benches. Let's get started with the functions. So functions and tasks. Those are like a group of statements especially used to perform a specific task. Perform a specific actions. So now a function or a task is a group of statements that perform some specific actions. In Verilog, functions and tasks help improve code modularity and reusability and readability. So a function task can be code modular by breaking into smaller blocks. So they improve the reusability because you can call them anytime. So instead of rewriting that code. And also they increase the readability by making the code easier to understand and maintain. So the task and function can be declared anywhere inside a module, but they cannot be placed inside the procedure block like always and initial. We can define or declare a function or task anywhere in the module, but not in the procedure blocks. The function can be called in the procedure blocks as well as the continuous assignment statement, whereas task can only be called from the procedure blocks. So this is a basic difference between the task and function. Okay, we can call this function from the procedure block or from the continuous assignment statement, but whereas the task can only be called from a procedure blocks. So we'll discuss with some examples here. So in Verilog, so every function and task definition must include a begin and end block. Okay, so definitely this is a thumb rule we need to follow, whereas in system Verilog no need to maintain a begin and end blocks, okay, in function and task, but in Verilog it should be mandatory. So now we'll see some examples and the syntaxes of function. Okay, what are the limitations, okay, on functions? So executes in one simulation time step. So functions complete the execution in a single simulation time unit, means in the single that in the same time step it will complete. So we'll execute all the statements written in the function can executed only in that time step only. So no time delays or event controls. So nothing but the function cannot contains constructs belongs to delays or maybe some event control like hash delays. We know that already we discussed at the rate event controls are non-blocking assignments. As we know that, so in case of non-blocking assignments, the evaluation of that right hand side expression is done immediately, but assigning to this LHS should be scheduled at the end of the current time step. So we never use this non-blocking statement or maybe delays or maybe any event control statements in the function. So only input arguments allowed. Function can only have input arguments, output or in-out or maybe, okay, these arguments are not permitted in case of Verilog, but in a system Verilog, so the function can allow both input, output and in-out argument also. So these are some limitations in Verilog. So we have only one input argument. The returns a single value. So a function most returns exactly one value. It should return at least one value, that too by using the function name. Now if you see the syntax of function, this is a function, a return type. So we are using some different data types, maybe integer, range, vibe. Already we discussed these data types. Function name, and it contains some input arguments. So we should specify the return type. So keyword function, return type, and the function name. This is a simple identifier, and we provide some input arguments. So begin and end are most in case of Verilog while defining the functions and tasks. So these are the statements, sequential statements. Okay. So to return something from the function, we are using the function name only. So function name equal to some results. So as a result to the function name means we are returning this value. Okay. So now end function. This is a syntax for a function. Function, return type, function name, and argument list, that to input argument. So this is a function body. So these are the statements or the sequential statement. We'll execute one after one another. So as we discussed, if you write anything in begin and end, all the statements will execute as sequential one by one. Okay. Now see in this example, just we define a function. Clear? So now function, this is the return type integer and function name add as a two arguments a comma b as a integer type. So now just I'll define a one function here, begin and end, add equal to a plus b. If you want to return anything from the function, then we'll use a function name only. So now I'll use a function name add equal to a plus b. This is the definition of function, declaration of function, where it is inside the module but not in the procedure block. So now just I'll define a simple add function, and then later integer x comma y, integer results. Now here is a one procedure block, initial begin, x is equal to 12, y is equal to 8. Okay, now I'll call the function, okay, by using like result equal add x comma y. What is the meaning of this, right? So if I write add x comma y means I'm calling this function like this. So if I write like this add x comma y, I'm calling this function by providing the two argument values. What are those? X is a 12, I'm providing 12, okay, and also 8. So add 12 comma 8 like that. So what is the value of a? Now value of a is 12. What is the value of b? Now b is the 8. In the same order, x comma y, a comma b, right? Now see, a is 12 and b is 8. Then perform the addition here. Add equal to 12 plus 8, 20. Now it returns this add, okay? It returns that value 20. Where should I store this? That whatever the value written by this function using a function name is assigned to the result. If I display result, okay, what is the value here? 20. X is equal to 12, y is equal to 8, sum is equal to 20. So by these are the x comma y comma result. So what is the meaning here? So while calling the function, then a will store this value 12 and b will store this value of 8. Then perform addition and return that value. This is a simple function definition. How do we define a function? How do we call a one function? Like this. Now a toss in Verilog is used for more complex operations that actually, so what is the basic difference between the task and function? It may contain some time delays, right, or event controls, whereas the function, okay, won't contains like delays or event controls or non-blocking statement, but the task may contains delay or maybe event controls. So it requires multiple outputs. Sometimes we expect multiple outputs where the function can return only one value. Okay, it returns only one value, but if we want to expect multiple outputs, okay, from that, then we'll define task instead of functions. So it can have input, output, in-out arguments, or sometimes like 0 arguments also. Clear? So the function has only input argument, whereas the task has input, output, in-out argument. Sometimes you won't give any argument also, right? Clear? So now do not return a single value like function. It won't return anything, okay, like a functions. So for example, we expect multiple outputs. Then we declare as an output. Okay. So I'll show one example, then you can understand. So this is a task syntax, task name. Whereas in the function, we'll use a function, some return type, because the function can return one single value, right? But task won't. So right, so don't return a single value like function. So no need any data type here, just simple task name. It has some input, in-out or output arguments, like you just, these are the arguments. begin and end task. These are the sequential statement. Okay. So now see simple example here. I'll define one module. Clear? To show how to define a task. How do we call a task? Now in this example, so just I'll define one task. So where I outside of inside the module, okay, but outside the procedural blocks. Clear? Task name is show sum. Clear? So now we can write like this also. Now here I mentioned this is the input x comma y 3 down to 0. So x comma y are the input for this function. Okay, what is the range? 3 down to 0. Clear? So begin, just I want to display this value of x comma y and x plus y. Okay, along with the timestamp also. Okay, what is the current simulation time? So now I'm printing the $time. What is the current time? Simulation time? What is the value of x? What is the value of y? And also sum of this x plus y. Now like that I can define a task. The begin and end are most. Okay, these are the keyword, the task and end task. Now initial begin a equal 4 tick t3, where b equal 4 tick 5. Just I'm initializing this a b as a 3 and 5. Now I'm calling the task. How do I call? Just by using the task name show sum a comma b. What are the value of a? A is the 3, b is the 5. Now if I call this function, then we go to this. Okay, sorry, if we call this task, then we'll go to here. Then it takes input x comma y, x is a 3 and y is a 5. Then we perform addition. Okay, then we'll print that value x plus y. What is the x value? X is 3, y is 5. Then we'll get x plus y is a 8. Clear? Now same way, then I provide one time unit delay. After next time step, I'm initializing with the new values. Okay, so a equal to 7, b equal to 6. Once again I'm calling the same function with the different values. Once again I'm calling. Then I go to this task. Now here what is the a value? 7. What is the b value? 6. Now x is equal to 7, y is equal to 7. Okay, then 6 plus 7, then here 13. So what is the output for this? At time 0, first time here I called this task. At time 0, the sum of 3 and 5 is 8. The sum of 3 and 5 is 8. Later, after one time you delay, once again I initialized with different values and I call once again. Then the simulation time unit is 1 and sum of 7 comma 6 is 13. This is the output for this program. I hope you understand how to define a task, how to call a task, okay, from the procedural blocks. Now this is another simple examples. Now here just I'll define one model to understand this task. So I define one task here. I declare simple task name having a 2 inputs x comma y is 3 down to 0 and also one output, okay, result 4 down to 0. So what is the result here? Result equal to x plus y. So what it is not function name, it is the output. See, this is the output. Understood? Now whereas in the function we'll use function name as a to return something from the function. We are assigning the value to that function name. By using the function name we are reading. But I declared the result as output. Now simply here initial begin a equal to 6, b equal to 3. Then add a comma b comma sum. Now if I call this task, what is the value of a? Now a is 6, b is 3. Now we are passing these arguments. A is 6, b is a 3. Then we go to this task and we'll perform some action here. Result equal to x plus y. Nothing but we are performing addition of these two inputs. X plus y, 6 plus 3, 9. The result, the 9 is assigned to the result. So what is the sum contains now? The sum contains the 9. So now if I display the value of a comma b comma c, now this sum of 6 and 3 is 9. What is the sum content? The sum is the output. After performing the addition of this input x plus y, the value is assigned to the result. What is the result? Result is the output. Now result is 9. Then what is the sum? Sum also 9. So we can display this sum value. Okay, here we'll get a 9. Clear? So now I declare input and output. For example, I want to require multiple outputs. Then you can declare here multiple outputs. We can use those values. But whereas a function has only one return type. Clear? So function can be used as operand in expression, whereas task cannot. So what is mean expression? Okay, it contains some operator and operands. So in any statement, the right hand side we can call as expression. Yes or no? Now we can use this function okay, used as operands in the expression, but task cannot. So for example, in this example, see, here I'll define one simple function. Function integer add has in two inputs, input integer a comma b, begin add a plus b. You can write like this also. Here add parenthesis input integer a comma b. Like that also we can write. Like also we can write. Now integer a comma b. So begin and end add equal to a plus b, end function. So now we declare result as a reg type 3 down to 0. Always at the rate begin. As we know that, okay. So at the rate means it take all the sensitivity list mentioned in this always block. Anyway, so now result equal to add 2 comma 3. Okay, function user and expression means, so now it is an expression. We need to evaluate this expression, assign to the value to the result. So now it is a single statement. So this RHS is an expression. So we can use this function. Okay, it can be used as a expression, as an operand in the expression. Sorry, it is an operand in the expression, but we cannot, for example, if it is task, okay, if it is task, we cannot call task like this. Okay, result display sum 2 comma 3. We cannot like this. Understood? Same here, I'll define one task. Okay, performing addition. Just this is a task definition, task name and inputs begin and end. Simply I use a single display statement inside the task. Now I can call like this. It is accepted. This is called as a standalone statement. Okay, we can call like this. Clear? It can perform. Okay, if I call 2 comma 3, then it display. Okay, a plus b. Okay, here, but we cannot write like this. Result equal to display of sum 2 comma 3. It is not acceptable. It shows an error. So task cannot be used in the expression. So there is a basic difference between the functions and tasks. So where these functions can be used as operand in the expression, but task cannot. Clear? So this is one difference between the task and a function. So assigned out equal to my function a comma b. What is this? This is a continuous assignment statement. So the function can be used in assignment statement also. Clear? This is the one operand. This is the expression. We can use function in an expression, but task. So we can use function in any expression as operand, but we cannot use the task. If you write like this, result equal display sum comma 2, what is this? This is a simple statement. It is an expression. Yes or no? It is access as an operand. We need to find the result and we should assign the result. Clear? We won't write like this. Now here I'll give some concept related to function and task. A function cannot call a task because function must execute within a single time step and cannot include timing controls. So what is the thumb rule we follow? Actually, we discuss function cannot contain any time related constructs or event related constructs. Yes or no? So function cannot call a task because task may contain some timing related constructs. Yes or no? Like hash, something like at the rate or wait statements. Timing related controls may it contains. So we cannot call a task because function must execute within single time step, within same time step, and cannot include a timing control. So we cannot call the task. A task can call another task or a function. Okay, because tasks do not have the same execution restriction as function. Clear? So now function should complete execution in a same time step, in a single time step, cannot contain timing controls, but the task cannot. So happily we can call the function or task. So tasks can be synthesized only if all the statement inside the task are synthesizable. Clear? In Verilog, the task or function can be called hierarchically also. So we'll discuss that also, right? Now see, this task can be synthesized only if all the statement inside the task are synthesizable. Most of the time, we'll use this task for test bench purpose. Clear? So these tasks are not synthesizable because it contains some timing related constructs like hash 10 or at the rate or maybe some wait statements. In that case, we cannot synthesize. But we can synthesize only if all the statement inside the task are synthesizable. Most of the time, the task contains some timing related construct, so we never synthesize. So most of the time, we'll use this task for developing a test bench. For example, if you want to develop a test bench, especially in a Verilog for any DUT, so we will use task only. By using task only, we'll develop a test bench. to generate a stimulus, to drive the stimulus, to monitor, everything we'll use it by using a task in a single model. Okay, for complex design it's very difficult, so we never use actually Verilog to develop a test bench. Clear? So this meant for actually design. So we'll use a system Verilog and a UVM. Later I will explain, okay, what is the advantage of system Verilog UVM over the Verilog. Okay, we never prefer this Verilog to design a test bench. Clear? Because right, if you want to design a test bench in Verilog, then we'll use, there is no option, we'll use task only. So a task or function can be called from another module hierarchically using the instance name. Clear? So now we can use a task or function can be called from another module, okay, by using like instance name hierarchically. I'll tell you one example. Clear? But what important limitation? Okay, we can call, but we have some limitation. This is only allowed during the simulation, not for synthesis. Clear? So now we can call, okay, function or task from one module, but it is allowed only in the simulation, not synthesis, not for synthesis. Now see simple example here. A task or function can be called from another module hierarchically using instant name. Hierarchically using instant name. So now just simply have a simple, I define a module, okay, module A. In that I'll define a simple task display, begin end task end module. Here I write just one single display statement in the task. What is that? It returns current simulation tab. So now I'll define another module, one top module. So now module top. So now I instantiate this module A by using an instance name A1. So A1. Clear? Now I instance a module A. Clear? Now initial begin. If I want to call this task, then I'll use this instance name. How do I call, okay, this task from this module top? So this task defined in the module A, but I want to call this display task from module top. In that case, I'll use some hierarchical name. Like what is this? Instant name is A1. A1 dot the display. Clear? I hope you understand. Now if I call the display task from the module top by using instant name A1 dot display, then what is the output? Task called from the module A at time 0. I hope you understand, okay, how the function and task can be called from another module, okay, by using this instant name hierarchically. Clear? Remember, so this is only allowed during simulation. Clear? Not for synthesis. Now another example, simply one example here. So module test and shall begin. I define one function where function can be defined or declared anywhere in the module, but not in the procedural block, especially in the initial and always. But here if we see where I define this function, add function definition inside the initial. So what actually function cannot be defined inside the procedure block. So you'll get an error. Functions cannot be defined inside the procedure block because we define the function inside the procedure block. Same way we see another example here. Here I define one model test. Here one function, okay, add, providing two inputs A comma B, and I'm returning A plus B. Actually in Verilog we'll use function name only. So in system Verilog we use this return keyword. It's not allowed in Verilog, but for understanding is it okay. So now actually we need to return this any value in Verilog by using function name only. So now this is a simple function. So now I define another task here. Task print message, string message is the input, okay, so string message #5. So display message, and I want to display this message. First initial begin int sum equal to add 10 comma 20. What is the meaning here? Now I am calling this a add function. Clear? So now I'll calling this add function, then I go to here, okay, what is the value of A? 10. What is the value of B? 20. No need, this variable may be different compared to this here, okay, no need to declare. In earlier case, okay, we have some variable A comma B, there in the function definition we have another variable X comma Y. Clear? So now what is the value of A? 10. What is the value of B? 20. Then just it returns A plus B 30. Now what is the value of sum? Now 30. Just I display the value of sum here. So here once again I am calling another task. Here I am calling the function, Okay, it is an expression we can use it in the expression, but task we cannot. So just I stand alone, I call this print message task. So print message, I'm providing the one message, hello, we Sagar ready. Now what it display? It wait 5 time minutes delay, then it is display that message. What is the meaning? The task may contain some timing related constructs. Clear? If I call this task, then it should wait 5 time minutes delay. After that, it display that message. So now what is the output? So first display here sum. After calling this task, the message is like the message is what is the string we are passing from this. Clear? So now hello we Sagar ready. Now message is hello we Sagar ready. I hope you understand how to pass a string. Clear? We can use these timing related constructs in the task, but we never use these constructs in a function. Clear? So function and task cannot be defined inside a procedure block like always and or initial, and functions and tasks can be called from the procedure blocks. Clear? So functions and tasks can be called from the procedure block, but we cannot define in the procedure blocks. So now here the difference between the task and function. So in case of function, it return a value, whereas the task does not return a value. Clear? But the task contains multiple output. If you want to multiple outputs from the task, we can declare multiple outputs, then we can use it. But whereas in the function, it can return only one value, that too especially in Verilog by using a function name. Uses in expression. So we can use this function as operand in the expression, but we cannot use this task in a expression. So execution time. Execute in a single time step. Because there is no delays allowed in the function, it should complete in the same simulation time step only. It may take multiple time steps. So in task may allow a timing related construct, you can write yash 5. For example, in the previous example, it wait till 5 time minutes delay. Then only it goes to the next statement. Clear? So it may take multiple time steps. So timing control like hash at the rate wait, not allowed in the function, allowed in the task. Inputs and output. The function contains only input argument. It can have only input argument, whereas the task can contain input, inout or output argument also. So calling other function and task. Can call another function but not a task. Function can call another function but not a task. Can call both functions and tasks. The task can call for both functions and tasks. Synthesizability. Synthesizability means here the function can be synthesizable. It contains only combination logic. Means by using a blocking statement. We cannot use a non-blocking statement. It won't contain any timing control statement anyway. But if you use a blocking statement, then it can be. Nothing but the statement written in the functions are synthesizable. Then the function also synthesizable. It is the task is synthesizable only if all the statement inside are synthesizable. Clear? So when the task synthesizable, if all the statement written in the tasks are synthesizable, then only the task should be synthesizable. In Verilog, all tasks and functions are static by default. Clear? So we'll discuss automatic function task in system Verilog playlist. So here in Verilog, all the tasks and functions are static by default. So what is the meaning? Meaning there is only one shared copy of their internal variables. Okay. So we allocate same memory. Okay. So one shared copy of their internal variables. Okay. Every time we call, we updated the value at the same location only. So Verilog does not support dynamic or automatic task function, which means you cannot use them in a recursive or parallel context safely. Yes or no? So it doesn't support automatic. Okay. So we cannot use in the recursive or maybe in the parallel context safely. And if you are looking to write a dynamic or maybe a recursive style logic, don't worry, we'll cover that upcoming system Verilog task and function, where automatic task functions are fully covered there. There in the system Verilog, this automatic task and functions are fully supported. We'll discuss in detail about this task and function in a system Verilog playlist. So just here I gave some glimpse. Okay, so we have so many limitations on function and task in a Verilog. We'll discuss in detail about these function tasks in a system Verilog. So in this video, we learned that functions are used when you need a return a single value without any delay. And tasks are better when you want to perform actions, especially those involving delays or multiple outputs. So both help improve your code modularity and reusability and also readability. So making your design more structured and easier to maintain. I hope the examples I gave a clear understand of when and how to use them in a Verilog projects. And if you found this video helpful, so don't forget to like, share and subscribe to the Sagar Techgate for more videos and Verilog and system Verilog content. So got the question or one more example, or drop a comment below. I will be happy to help. Thank you very much.